All right, welcome back. Been a while. It's been quite a few months in terms of making videos. Been traveling, doing some training. Uh, so yeah, I've been working, but yeah, I've been extensively traveling. Have been doing a lot on the road stuff. For those of you who don't know, I also do training for technicians as well. So have to catch up here with the videos here on YouTube with Diesel Talks. So therefore, welcome. Thought I'd do a quick one on communication. I was recently, buying some engine oil, doing the oil change on one of my vehicles, and it was really frustrating to see, some do-it-yourselfers wanting to say, "Hey, I got a bad computer." So one of the things I always talk about with technicians is that, do what's going on with the computer? A lot is going on with the computer. So therefore, please note, if in case you don't know. The computer has got many different functions apart from just keeping the engine going and responding to different conditions, but also meeting emission standards. Okay, there are emissions. So therefore, the PCM, ECM, whatever you want to call it, powertrain control module, engine control module, whatever it might be called, it does many different jobs. So thought we'd do a quickie on communication, because just because you hook up a scan tool, or maybe you take it to your local auto parts and want to get it scanned to know what it is, there are some things you ought to know. It isn't that simple. You see, there's something called emissions related protocols, and then there's the manufacturer specific protocols. And if you are, Mr. Ford Motor Company, Mr. Ram, Dodge, whatever, Mr. Ford, you don't want to be easily your stuff being used. So therefore there is, some protections that manufacturers will keep, but that's a separate subject. All I'm saying is, we have to use a scan tool, but us as professionals that work in the service industry, meaning the, repairing trucks, we have to buy these scan tools, and you see these guys selling you these scan tools that will tell you a whole heck of a lot, but it's all based off a database. It's like, well, if you get this kind of vehicle and you got this kind of problem, you got this kind of code, most of the time it's this, most of the time it's that. And what about when it isn't? So that's where us technicians. So one thing I stress to techs that I train is that, you ought to know how things work, and you ought to know why it happens, when it happens, and why it happens. So, and then to prevent it from happening again. So let's get into this little slide presentation real quickly. Where does communication start? Somewhere underneath the dash, usually on the driver's side, it should be. You're going to find that there is a diagnostic link connector, aka known as the DLC, data link connector. Well, when you connect the scan tool, I don't care who's you hook up, it's all the same thing. It's a 16-pin connector for light duty and certain medium duty vehicles. The big stuff, either heavy, medium duty, and class A, meaning big trucks, those use different connectors, which we call the Deutsch connectors. So they use a different kind of connector for those bigger trucks. But light duty trucks and certain medium duty trucks will use what you see here is the diagnostic link connector. So this is where all communication. So when you talk about codes and you talk about things that are going on with codes, it all starts at the data link connector. So the problem that many people have, both on the professional side and on the do-it-yourselfer side, is that many don't know what to do when the scan tool does not communicate. Okay, what do you do when you don't communicate? So the first thing you ought to know right off the bat is pin 16. As you can see, it's a 16-pin connector. It is a standard connector required by OBD II law, onboard diagnostics. And you'll see pin 16 is battery power. It always has power. Some vehicles, it's often tied to the cigarette lighter or power unit fuse, that has power for your, your little cigarette light adapter, which is now called a power probe. But in this case, it's battery power. So therefore, that's positive battery power, pin 16. Then you got the 4 and 5s. One is a chassis ground, one is a signal ground. So in this case, you're going to see that there is ground located there. So in this case, you literally can take a meter and put a voltmeter between 16 and 5 and 16 and 4. That'll tell you got good battery power and ground, but it doesn't make sense to check that if you don't first reference battery voltage. So you got to open the hood and look at your batteries and measure the battery voltage. So in this case, what is the battery voltage? And then compare it to see if you got any drop. In other words, if your battery voltage is 12.8 and you got 11.9 at the connector, yeah, we got a problem. We got quite a bit of drop of voltage there. So therefore, that's one of the first things you always want to check when you got a scan tool that doesn't want to turn on or doesn't want to work, because many scan tool adapters, excuse me, are using the power off this data link connector, which again is pin 16, 4, and 5. And you don't have power. Sometimes what you got to do at pin 16 is go check the fuses. Like I was telling you earlier, You might want to check your SIG or power adapter fuses and see if those fuses are burnt, because many people overload the factory connections for the cigarette lighter or power adapters, and they'll try to power up everything they have, from cameras to cell phones and so on. And many a times they often burnt the fuse. So therefore, check the fuses, and there is a fuse for pin 16. So therefore, that's something you got to look up on the truck and know what to do. Use your not your service manual, but your owner's manual that will actually help tell you what fuses are go to what. So there you go. So that comes to communication, but we'll get into that here in a second. But in order to understand networks, you need to know your pins. Bottom line, what are the pins? Again, I just covered pin 16, which is battery power. 4 and 5 are grounds, but then we got to look at communication. Now, to working technicians, I often tell them, you also need to check the cabling between the scan tool and your scan tool adapter. And what happens is that sometimes we have to go ahead and make sure that the cable is not the problem of why it won't communicate. But things get a little bit diverse, but we're trying to keep it simple for you guys that are do-it-yourselfers. So there is history to the diagnostic link connector. The 16-pin was a standard that came in all vehicles, mandatory since 1996. So anything 1996 or newer will have the 16-pin connector. But some trucks like F-254s, you may find one on a 95 model, which is located more towards the passenger side in the middle underneath the console. But other vehicles like, an old Chevy Blazer that I used to have, the 95 model, did have the OBD II connector, which many call this the OBD II DLC. So again, it's not surprising that it's called OBD II connector, because that's what brought it about. Onboard diagnostics generation 2. But please remember, as you're looking at this, there is onboard diagnostics, and meaning that this guy is supposed to diagnose himself, not necessarily. And get this clear. Let's get this clear. Look at me here. This means that this is for emissions-related malfunctions. Emission-related malfunctions. Now, if you're from the old days, I mean, right here in my office, I got my old MasterTech scan tool where we had different adapters back in the day from 95 and earlier. We had a Toyota adapter, we had a Nissan adapter, we had the Ford Doghouse connector, the old 12-pin connector for GM. So it's kind of sucked back before. So we kind of welcome this connector being mandated to all manufacturers, because there were so many adapters that we needed to have. So therefore, that didn't work very well for us, because, there were so many adapters. So with that said, yay, we like the fact that we got the 16-pin connector, because one guy plugs into all of them. So here's my OBD II breakout box, as we call it. So, take a look at this right here. This is my OBD II breakout box. It has a bunch of pins right there. Let me turn it around there. So in this case, you're going to see that this is an OBD II breakout box. And you'll notice it has all 16 pins. And what I can do is I could literally plug it in. Okay, I could literally plug it in into the vehicle. And I could even, on the box on the side, you're going to be able to see that there's that 16-pin connector right there where I can plug in my scan tool. So this allows me to go ahead and probe and test these pins to see what's going on with them. But that's more of a professional thing, but it keeps us from hurting the pins. Now, those of you guys that love to play with tuners, there's the downloadable type. And a lot of you guys will go ahead and plug in, plug. Quit doing that, because these pins on that OBD II connector were not designed to be constantly plugged in, plugged out, plugged in, plugged out. And that's a problem, because we have often found the pins, or cavities as we like to call them, inside of this 16-pin connectors that actually push out, and then it won't make contact. So one of the other things you want to do when you got no communication with a scan tool is you want to check to see that those pins are not pushed in. Okay, they're not pushed in, because there are middle contacts. Those are the ones I'm talking about. Pins refers to the middle contacts inside of these cavities. There's 16 cavities here. So the middle contact is actually needs to be checked. That's inside, that makes contact with your scan tool there. So there you go. Now, certain manufacturers have pins reverse numbering of the OBD, but actual placement of the terminals is correct. So in other words, they're upside down. So therefore, you might find the connector, like I said, you might find it like this. As a matter of fact, let me go to full screen here. And when I say about this is that, you're going to see right here the OBD II connector there. So therefore, you're going to find that sometimes it might be installed this way, or it might be installed this way on the vehicle. So therefore, it might be upside down. So therefore, let me get that camera done. There you go. So in this case, you might have it upside down. So it all depends. Sometimes faced angle this way, but it's usually underneath on the driver's side, because it was mandated by law to be in that placement. So therefore, yeah. So what am I going to do? If I have an issue, I can often use my breakout box. Again, you can get creative with yours. these breakout boxes were in design. This is one from Blue Point Snap-on, but in this case, I got pretty much, let me look at this screen. You'll notice that I got a 16 pins. So if I'm going to 16 and 4 and 16 and 5, there's my battery power. So there you go. So therefore, that's what you need to check first. That's a fundamental test that you ought to be doing first. So if you don't do it, then you're going to be in trouble. So that's not good. All right, so moving along, let me get the screen back up for you. And here we go. Come on. Thank you. And in this case, we'll move on with communication. So we're just going to, again, this is just a brief overview of understanding the basics that you ought to be checking. So it is helpful. But again, you got to take care of it. So when you look at the assignment of the pins, you know, there are OEM discretion pins. In other words, there could be different subsystems. Like when I was doing training with General Motors, you know, we had, I remember the old Chevy pickup with the four-wheel steering, you know, so therefore that was a separate system in itself for the rear steering. Look at it that way. So that means they had to have a protocol or somewhere to communicate with the scan tool, because you see, it isn't all just about engine. There's transmission, there's ABS, there's traction control, there's body features, air conditioning, there's radio. I mean, the list goes on and on. I mean, if it's got, you know, some type of, like OnStar on the GM, you know, Ford has their own proprietary systems. Those got to be able to communicate to the scan tool under a different protocol, because there is powertrain only stuff, and then there's body other stuff, which I'll show you towards the end to help you understand how that all works. So, but then there is J1850, which is actually, again, a different protocol, along with 2284, which is CAN communication. That's the one we're going after in this presentation. The 2284 CAN is controller area network. Pretty much all manufacturers are speaking, or actually are moving away, because there's now LIN networks, and that's another subject in itself. But in this case, the CAN communication means that's powertrain. So 6 and 14 are your other major guys, okay, for powertrain communication. So often we tell guys, hey, if you do have a professional grade scan tool, you know, what you're supposed to do is you're going to do a master scan, and a master scan means it scans everything on, you know, Ford likes to call it a network test on IDS. You know, when you use a WI Tech 2 for a Dodge, these are factory scan tools, by the way, you know, it'll actually do a complete network and show you the network on a pretty picture, you know, on a screen. That's kind of nice. But then when you use the GM, same thing. You're running a test to see, is everything communicating, you know, and is everything talking. So when I get into an old vehicle, you know, and I turn the key on, fire up the engine if it runs, you know, all these lights are on the dash for other subsystems that are equipped on the car. Well, that means there are problems in those subsystems too. But for now, what we need to understand is that, you know, you have to know that there are different protocols or different languages. Look at it, languages. Some are fast, some are slow. When we talk about over 333,000 bits per second, we're talking that this thing turns on and off so fast. So we can compare that communication with Morse code. You know, Morse code is nothing but on and off signals. You know, it's short or long signals. So it's beep, 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 beep. So therefore, you know, what does that mean? You know, so therefore, that's what it's based on. That's what we call binary communication. So in this case, how does a scan tool, or how does a computer talk? It talks from on and off signals, okay, which ranges on the average with CAN communication, control area network. It averages between 0 and 5. There are slow speeds, there are medium speeds, and there are high speeds for priority. There are some things that are priority. In case you don't know what I mean, look at it this way. The classic example I give in my classes is, hey, you got a vehicle speed sensor that tells, you know, you look at your dash and you could read the vehicle speed, but there's a speed sensor usually on the output shaft of the transmission, right? Output speed sensor. But hold on a second. The engine management needs to know that, so that's one. What about the transmission? Yep, it needs to know engine vehicle speed. That's 2. What about ABS, analog brake system? Yes, it needs to know that. What about traction control? It also needs to know that, right? The radio, the air conditioner, and so on. So you can take one input and have over 5 to 6, 7, 8, 9 modules, depending what's equipped on the vehicle. And that will use the same information from that one sensor. So therefore, how does that speed of the vehicle get transmitted to everybody else? All these different modules, from body control modules to ABS modules, so all these different modules, how does it talk to? Well, there's a network. So it's computers talking to computers. That's what we see happening here. But where does it start? It starts right here on the diagnostic link connector, where you're communicating, because what you're doing when you connect the scan tool For us, this isn't just about codes, getting error codes. It isn't just about error codes. It's also about data and tests that I may be able to perform. But this is my portal in here. That's what I'm looking at. So once again, battery power, repeating again, is 16. 4 and 5 are grounds. And then 6 and 14 are controller area network, or again, on and off signals or communication. So 6 and 14 are for pretty much everything. And when it comes to drivetrain or powertrain, in other words, mostly engine management. But please note, what drives this is mostly emissions, but then everything else is secondary. So therefore, emissions is the main target. Here in Clark County, Nevada, for example, we actually have emission testing, but for certain light duty, not diesel, but gasoline, in order for you to pass emissions, in order to be eligible to pay for your registration, we have to go get a smog check. The smog check is not about sniffing the pipe. It's about plugging into this, and they're going to see if there's any related emission codes and certain monitors that have been passed and run. So therefore, they've been running past. So therefore, the computer should know if he's running dirty. Okay. Yes, that's what it's all about. So I'm trying not to get too technical, but if emissions exceed, again, hear me out. If emissions exceed 1.5 times over the federal test procedure limits, the check engine light or malfunction indicator light must illuminate. That's law. So technically, the check engine light or the malfunction indicator lamp is there for what? It is there for emission purposes. So guys will ask me, hey, Tony, why did the truck have this problem, but yet it didn't turn on the light on the dash? In other words, the check engine light. Well, it's because it probably was not emission related, or the computer was able to keep that vehicle or truck running without having to violate emission laws. See that? So therefore, that's what you see there. So again, 6 and 14 are chat lines, as we call it. But then there's gateways, like early Dodge Ram models actually had a gateway. If you open a, early 6.7 or early 5.9 Cummins, between 03, 04 and later, you're going to see, you open the hood and you're going to see right there on the driver's side, you're going to see the fuse box, right? It's a fuse box. Well, no, it's called a TIPM, a totally integrated power module. Yes, it does look like a fuse box, but underneath it, right underneath, there's a module in there, which again, we call the totally integrated power module. Try on an 07, try looking for the flasher relay. Where's that flasher relay? There isn't one. It's actually part of the TIPM. So if your signal lights quit blinking, it actually could be the TIPM module needs to be replaced. Literally a module to be replaced. So therefore, but that module is the gateway. So when I communicate with the scan tool, I first talk to the TIPM, and then from the TIPM, it takes off like a route and talk to all the different modules like ABS, transmission, and engine. Those are 3 separate modules, but I don't want to get too technical. But General Motors trucks on certain models, they actually have a BCM, a body control module. That is the gateway. So when I want to talk to a onboard computer, it all depends how it's set up. Who am I talking to first? So when we do diagnosis, like, here we go. How do we know? You got a bad computer, like I started this presentation. There's a lot more. So when you're doing trial and error, and this is what really pisses me off, and I'm going to say this out loud. This is what really pisses me off. Even in Facebook groups and other social media groups that I see, the guy has all the money to actually, I'm trying out this sensor. I put this sensor, didn't work. I put this sensor, didn't work. I put this actuator, didn't work. I put this sensor, and I put this sensor. You must have spent, you moron, probably over $600 to over $2,000 in parts, but you don't got the money to go take it to a reputable diesel repair shop to scan it for you. At least pay for the diagnostic fee. That would have been a lot cheaper than all the damn sensors. So in this case, what I'm saying is, quit replacing stuff and do trial and errors, like rolling the dice here in Vegas. Come on, sevens. Here at the tables. So all I'm saying is, be smart about this as well. You can do these basic checks that I'm telling you, powers and grounds and so on, right? But at the same time, you need a scan tool. You cannot function if you think your tuner is going to do it. Tuner's another generic scan tool, doesn't tell you a whole heck of a lot. That's why us technicians pay the big money for those tools. Yes, I got over, I don't know how much money. I got a lot of money in scan tools alone because I need them. This is my tools. It's just as important as my inch drive ratchets, my 10 millimeter wrench, my 10 millimeter socket. It's just as important of a tool. So continuing, sorry, I'm over it. Quit replacing parts. Sometimes you might get lucky, I know, but anyways, no gateway. Yeah, who does not use a gateway? Some parts, Ford trucks do not use a gateway. They actually just use. Let me just show you the wind as we move along. So here we see a, I think this is a Dodge. Yeah, this is Dodge application here. So when we look right here, here you can see a diagram. Now I'm not going to go in depth into this, but we can see that there's the battery and there's fuse right here. And we will notice here, here's our data link connector here. So there we go. Here's our data link connector there. And in this case, what I'm showing there is there's a pin 16, there's pin 6, and there's pin 14. Okay, I could see the 14. I don't know if you can see it. There's a 6, and then there's a 4. There's the cursor right here. Hello. So here's your data link connector, and there's your 2 grounds, 4 and 5. So when we follow 6 and 14 out of there, it goes to this gigantic box. Follow these 2 wires here. Again, it's like following a map. So I follow these 2 wires, and I see this box right here. So they go into this box. What the hell is this box? Well, this box is the TIPM module, totally integrated power module. So this is the TIPM. So from the TIPM, it actually takes off to other modules. So you'll notice here's CAN C from 6 and 14 of the diagnostic link connector. Here's another 2 wires. Here's another 2 wires. So in case you didn't pick that up, CAN is 2-wire communication, 2-wire communication. So that's what we see going on. So when you sit there on the Dodge Ram in your local auto parts store and you got the ECM in your hand saying, I need a new computer because it wouldn't communicate or it doesn't work right, there's more than one module here. So here we could see a TIPM module on a certain Dodge Ram product here. So you're going to see more and more other junction blocks and so on of communication. I mean, this thing goes on and on. So that's why us as technicians got to study up and know this stuff. And this is what I train on too. So therefore, all I'm saying is that, well, you know, what you think is communicating to the ECM is not. There are other subsystems involved. Hell, Dodge on the early years called their dash, which is also a module, you know, where you display your speed and your gas and all that. That's all like a module in itself, which they called a cabin compartment node, better known as the CCN. So there you go. Now Ford, like on a 6-liter, you're going to see here that they actually have pin 6 and pin 14. There it is at the bottom here. This is a simple one on a 6-liter. So there's 6 and there's 14, like I showed you off the diagnostic link connector. This lazy 8 represents the wires are twisted together. Okay, it's a twisted pair of wires for interference. They're trying not to get any interference. So in this case, we follow those 2 wires, whether being a pickup or excursion model, circuit 144 on a pickup, circuit 133 on this side for a excursion. It's a pink and yellow wire and red and white wire that goes to the PCM, the powertrain control module, which is located right there on the driver's side next to the battery. But you'll notice there's another 2 CAN bus wires that communicates with another module, which is the FICM. Those of you that know what a FICM is, fuel injection control module. So it's shielded and it's also got a twisted pair of wires to protect it again from interference, electromagnetic interference there. So this is a rather simple one that the Dodge you just saw. It is directly, as you can see here, communicating straight from the DLC to the ECM. So you're taking a straight shot there. So there you go. When we look at some Dodge applications, here this is early model, like a VP44, like a 99, 88, 2000, 2001 model that have the VP44 pump. This one's a little tricky because this one actually is multilingual. So, oops, let me get this over again and move it over. Sorry, PowerPoint's bringing it out to me, but there's your pins. There's 16, which is, you know, power. There's your 4 and 5s, which go to ground. So therefore, I got to have, here's my 2 grounds right there. And then you got all these different communications to a PCM. And then you got other communication going up to the top to the TIPM module. So in other words, it's more diverse, you know, a lot more diverse. So obviously, I'm not going to go in details. But then there's other protocols. We just saw the 6-liter, you know, but now there's other protocols. You can see here, we got the PCM. Okay, there's the PCM. But then we got another module, auxiliary powertrain control module, the passive anti-theft module, the instrument panel cluster. And these talk on 2 wires too, but they're not using the 6 and 14. It is not CAN communication protocol. It talks on pin 2 and it talks on pin 10. So there you go. Another 2 pins being used. But this is for SCP bus. It will use in the early years, you know, standard communication protocol bus. So this is not CAN. This is a different language. And that's what we see going on there. So again, I'm just trying to make you aware that there's a whole heck of a lot more going on than just a wire going between your scan tool all the way to the computer. So Here's a General Motors product where they're using a low-speed bus. So here we can see the data link connector, and there's no standardization on the wiring diagrams or schematics. Again, there's 4 and 5, your grounds. There's pin 16 right there going to the, there's your, your fuse, your lighter fuse, like I said already. There it is, an example. So if that fuse burns, no power on 16. And then you got pin 1, which is another single wire communication. So, and that talks on one wire. And here you could see this box right here, which is again the distribution box of signals. And just by looking at these little dashed boxes, you're going to see that represents a module. So in case you haven't caught on, chime module, radio module, door lock, radio window switch, passenger side, door lock, window switch, driver's side, and you got all these different ones. A lot going on with communication. So, when you come across a problem when the door locks don't work or the power windows don't work, guess what? We're scanning too, so therefore you're looking at that as well. Here's another one. Here's a General Motors truck here, pin 6 and 14, once again right there. So again, you follow that. So the way they actually put the symbol for twisted wires is this kind of weird line symbol here. I don't even know what kind of symbol it is, but anyways, it does represent twisted wires right there. So again, we follow the wires of 6 and 14. This wiring diagram is multi-use because it actually is for all different models. So let's look at it from a big standpoint here. You'll notice that 6 and 14 are right here, if you can follow my cursor, okay? And my God, we call this a bus system. If you think about it as a bus route, if you ever taken a bus, there's a route, there's a terminating station, then you turn around and come back to the first station, blah, 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 and then there's stops along the way. Well, that's what we're doing here. So let me get my highlighter just to show you the bus here. So in this case, I'm using one wire here. So here we go. So here's 6 right here, and I'm going to follow the bus and just follow the bus. Obviously, there's 2 routes. I'm going to take this route, and this, sorry, my mouse is in my finger, but this is the route that it's taken to communicate. So as this bus is trying to communicate to finally this guy right here, this is our terminating guy. This is the ECM, the engine control module. And then you're going to see it come back. So therefore, let me change color here. So yeah, it's a lot going on here. Come on. So in this case, let me come back. Let me use a real dark color here. So in this case, you'll notice that from the terminator, it comes back. Look at it that way. Obviously, these 2 wires are doing a job. Theirs is to communicate, but you'll notice they communicate between modules right there. So therefore, look at all those modules in play there. So therefore, that's what you see going on there. Sorry, my cell phone's on. So therefore, what I'm trying to say is, you got a lot going on here. But if I want to talk from the scan tool, so this is where I connect my scan tool right here. That's my diagnostic link connector at 6 and 14. And I want to talk to that ECM, which is this guy right here. You got to go through how many modules along the way. You got the junction block here, you got the transfer case control module, another junction block, then you got your glow plug control module, then your power takeoff control module, if equipped, transmission control module, and finally to the engine control module. So yeah, a lot going on there. So therefore, definitely is going to be a lot to understand. Now, we didn't even get into this side here. So there's more that goes all the way to this terminating resistor. So again, all I'm trying to make you realize is that there's more to the picture because you got to look at the options that the truck was at. I don't care if you have a 2001 truck, like a Chevy, that Chevy actually has what we call class 2 communication, single wire, but it has a lot of those modules. It has a driver control module, it has a passenger module, has a body control module, has a radio, has air conditioning. Those all talk in the scan tool. Yes, certain systems with air conditioning control modules, I have to connect the scan tool to talk to it to see if it has any malfunctions. Like, the blend door doesn't work, the actual mode door that, puts air up to the defrost, to the face, to the floor, that can also be a problem too. So pay attention there. So here we can see a blown up view of, what's going on from you could see the glow plug control module going to the power takeoff control module right here. And then it'll continue on. I just try to blow it up so I can put it here. So finally to the transmission control module, finally engine control module. So CAN communication is 2 wires. That's 6 and 14 that we started off talking about. So as we end this, let's just show you here a basic overview. I know we're looking at this is a Cadillac XLR, I believe it is. But in this case, just to show you, because today's trucks, like a fully loaded Denali, a Platinum from a Ford, or a Laramie from Ram Dodge, you got a lot going on there. I mean, we got air conditioned seats, for Christ's sake. We got GPS, we got these big screens now. And today's instrument cluster is one big ass LCD screen, but behind it, it is actually a module in itself. So with that said, what I'm saying is, what is going on with communication? So this is old technology, but it's now evolved so much. So when I look at 6 and 14, you're going to see I'm first talking to the body control modules. Then you got all the other modules in play from, again, your transmission, suspension control module on the vehicle if it's equipped, electronic brake control module, which is your ABS. And if it's got steering control, you got that. And finally, the high-speed CAN will reach over to the engine control module right there. But that's not it. There's more subsystems on the vehicle, those conveniences, as we call them. So then you got single wire communication that you connect to the scan tool. So if you need to talk to the radio, the heads-up display if equipped, or another kind of VCI, vehicle control interface module of any kind. And then you got another pin 2, which we call class 2 single wire communication, talking to the HVAC control module, the door modules, driver memory module. And you got all these different modules there. It isn't surprising to say that today's trucks have probably an excess of over 12 plus modules, all the way to 40 probably, depending on the options on the truck. There's a whole heck of a lot of communication. So when you come into that local auto parts store, hey, that local auto parts store loves you, man. He's going to say, I'll sell you whatever, because there's a returns on computers. No, there isn't. Once you take that computer in your hand and you put it on the vehicle, it's yours. Well, it didn't start the truck. It didn't fix the truck. Yeah, because there's something else going on. So the question I asked techs, to be fair, you guys do it yourselfers, I understand. But let me look at the technician, the working technician, a good working technician, not some backyard wannabe mechanic. All I'm saying is, I ask them, how do you know you got a bad computer on a truck? The answer should be, after I check everything else. Did I check everything else? So with that said, we have to see the big picture. So quit wasting money on just replacing parts. What are you going to do? You might have gotten lucky. Maybe you bought this part, it fixed it, it's done. Okay, you got lucky. But what about when you don't get lucky? That's why it pays to get a diagnostic from a good, reputable shop. So check their reviews, so on. But all I'm saying is, you got to understand there's more to the picture. Now look at this and imagine that this truck was in a flood. Or maybe it's a wannabe four-wheeler who likes to take it deep into the water of the river or creeks. What are they doing? They're just getting a lot of those connectors wet, and then eventually that causes weird things where things start flashing on the dash that don't make sense, or maybe the ignition key won't work, or the push button won't work. What do you do now? So therefore, it's all wires talking to each other. And as we are approaching the 2022, 2023 model years, the gauge wire and thinness of these wires are so thin that they're becoming more sensitive. So we're starting to see pigtail connector problems and so on. That's why I love that Ford for the longest time said, hey, perform the wiggle test, wiggle stuff around and see if you see something going on, that may cause your problems. But it all starts at the battery, which is another presentation I'm going to do later on. But in this case, we got to know how to charge properly a battery and how a battery basic works. So for now, again, what's pin 16? Battery power. Pin 4 and 5 is your grounds, and 6 and 14 is your communication. So I'll leave it at this, but this is more advanced stuff, but I'll leave it at this. If I want to know if it's talking on 6 and 14, so remember that breakout box I showed you earlier? Okay, I'll connect this to the truck, and I'm going to probe right here, and I'm going to go from 6 to ground, 14 to ground. And which were the grounds, right? The grounds were 4 and 5. So I can go from 6 to 4, 6 to 5, whatever you want, and 14, which is, look at the chart right there on the screen. Look at me here, look at here, there. 14 and 6 are the communication. So I'm going to go 6 to ground and then 14 to ground. Well, on average, it should reach somewhere in the neighborhood around 2.5 volts. Why is it 2.5 volts? That's a whole nother class. But for now, I just need you to make you aware of what's going on with communication. So that's it. Sorry, I've been absent so long. I'm back. I'll be seeing more videos. But anyways, thank you for watching Diesel Talk. Give me a comment. Hit the like, subscribe, whatever. I never do that. But you want to join, you want to join. You want to see some stuff, then fine. But in this case, I appreciate you watching. And we'll see you next time. Bye. And how do I turn this thing off? I gotta try to turn it off.